unit circle at all? Okay. So kids, we're going to start working on this new idea today, what's called known as using sum and difference formulas, all right? There's going to be a bunch that we look at here in a little bit, but what we're trying to ask ourselves is this: how can you evaluate trigonometric functions of the sum or difference of two angles? And when we talk about two angles, we're talking about the two angles that are going to be used from your unit circle there, okay? And I'll show you what's going on here in a bit. But guys, in order to answer the question, we need to be able to use sum and difference formulas. Sum meaning what operation, kids?
Addition.
Difference meaning to evaluate and simplify trigonometric expressions. And so we're going to be doing some simplifying. Then we're also going to use the sum and difference formulas to solve trigonometric equations and rewrite some real life formulas, okay? What's most important for you guys today is right here, all right? Super duper important. Oops, wanted to. Super duper important right here. All these formulas right here. So kids, we're going to be talking about two different kinds of angles, an angle A and an angle B. And guys, right here, suppose you had the sine of like maybe, I don't know, 30 degrees plus 80 degrees. They say this is equivalent to what?
Sine A cosine B plus cosine A and sine B.
So like right out of the sine A and cosine B, what operations really apply between those two trig functions? Multiplication, okay. Now guys, which of those three up there, the sum formula is on the left and the difference formula is on the right, sine, cosine, tangent, which one of those look like the most difficult to work with? Tangent one. The tangent one's not going to be much fun, okay? We'll work our way through that as we do stuff today. Sorry guys, I lost the contact. Well, anyway. I think so. How many of you guys wear contacts? Anybody? Can be kind of tricky sometimes, okay? So we'll kind of get started on this right here, guys. Example 1 says to start evaluating trigonometric expressions. Now, kids, here's how this is working. We've got some formulas up here. We're going to use these formulas to work with some sum formulas and some difference formulas. The key thing that I want you to pay attention to is this. When you're starting to solve stuff right here, or find stuff, this gets pretty interesting. It says find the exact value of what? Okay, now if I punch that in my calculator, it would give me a decimal. That decimal is simply going to be an approximation, but it's going to be really, really close. Take a look at your unit circles, kids. You see 75 degrees anywhere in your unit circle?
Yes.
No.
No.
75 degrees show up there?
No.
Not at all. So what we're going to try and do is say is this. Is there a couple of angles or a pair of angles that I could use to form 75 degrees? In other words, from that unit circle chart, are there two angles that I could use to either add or subtract to make 75 degrees?
Yes.
Which ones do you want to start with?
30.
Is 30 degrees part of your unit circle?
Yeah.
Is 45 degrees part of your unit circle?
Yes.
So what we're going to choose to do here, kids, is this. Okay? We're going to call the sine of 75 degrees here. We're going to call that the same as the sine of, what do you want to put first, kids? 30 or 45?
30.
Okay, we'll put 30. Now here's the deal. I would tell you the order wouldn't matter. Okay? Now I'm choosing 30 and 45 because those values came off of which chart? Unit circle. You got to use values that are on that unit circle chart to form what you're trying to find the exact value of. Okay. So guys, what we say here is this. Okay, I've got a sine function. I've got a sum formula right here. So we're going to use the sine formula for the sum of two angles off of our chart. So here's how this works. Take a look up there, kids. You see the formula right up there? I'm going to kind of make it so we can use it. But let's suppose the A value in this is like what angle? 30 degrees, and B is like what angle here?
49.
Okay, so the sine of 75 is going to equal the following. Okay, according to this rule, it's going to become the sine of my first angle, which would be sine of what?
30.
Okay, times what?
Cosine.
Cosine of the second angle, which would be cosine of
45.
plus, okay,
Cosine 30
cosine 30
times sine 45.
Okay, so this is where things get kind of interesting for us. We're going to evaluate this here to get an exact value. Okay, so we've used the formula up there. I'm going to roll down here quickly. So guys, on your unit circle, what is that sine of 30 then? What do they give you as a sine of 30 on your unit circle? 1/2, you said, Katie?
Yeah.
Okay, so the sine of 30 is going to be 1/2. I'm going to write that right here. Okay, so this becomes 1/2 times, what's cosine 45 get you? Square root of 2 over 2. Okay, that's the first two, it's sine 30 and cosine 45. To that we need to add in what next, kids?
Cosine 30
Which is?
square root of 3 over 2.
And how about sine 45? What do you have for that?
Square root of 2 over 2.
Okay, you guys with me on that?
Yeah.
Now are 30 and 45 the only ways I could have made 75 degrees? At least by addition, but could I have done like 105 minus 30 also? Okay, so guys, there's going to be multiple ways to do this, all right? Okay, so let's talk here, kids. On the left side, what's 1 times root 2 up top? So this becomes root 2 over 2 times 2 on the bottom would be? Okay, plus, okay, what's root 3 and root 2 going to multiply to over here? Over what? Okay, so the nice thing about this, kids, is this. What's true about your denominators down here? Okay, so what we end up with here, guys, is this. We end up with the square root of 2 plus the square root of 6 up top, all over what common denominator? Okay, and there is your exact value right there. All right? Are we going to get some nice looking answers or some things that are kind of weird? Okay, so here's what I would suggest you do once you have an answer. Let's jump into our calculator. So if I go here, if I pull up my calculator right here, I want to go, so I'm going to go square root of 2 plus the square root of 6, and then divide that by what now, kids? Okay, so I get about 0.9659. Remember that, 9659. Can you do that for me? Questioning if you're right or wrong on this stuff for exact values, what I'm going to do now is I'm going to go ahead and type in sine 75. And if with a little bit of luck, what should happen with our decimals?
Be the same.
Should be the same. 0.9659. That turn out the same? Okay, so exact value, what do you get? Is it working for you, Laura?
What did I do wrong?
Yeah, I got 1.6.
I got 0.52.
Are you in radians or degrees? Make sure you're in degrees.
Leave it on the old phone.
Type in sine 75 again.
0.9659.
Oh, it is, it's just
No,
normal.
no, you got the square root of 75. Sine.
Oh, is that what it is?
Sine 75 is what we were after, right?
Yeah, but wait, when I do the other one.
So you're going to have to go square root of 2 plus square root of 6.
Yeah. And the red.
Oh, hang on a second. Hang on, you got to type it in like this. You got to go, where's your square root button? Get up. Square root of 2 parenthesis plus.
I tried that, so maybe it was answer. I got what Caleb just got.
Now divide that by 4.
What's wrong with doing it like this?
They want you, okay, so your order of operations is actually dividing root 6 by 4 first, so you gotta hit enter before, so like the root 2 and the root 6 part, you gotta hit enter first.
But I got like a 0.5 thing when I did that before.
What did
Go root 2 plus root 6.
But you have
Gotta make sure you put parentheses all the way around the 2 and all the way around the 6.
Oh.
I was just like this, I was like,
Because the way you're typing it in right there, Cora, it makes it think like, your calculator thinks you're doing the square root of 2 plus a square root of 6 in here like this. So it thinks your calculator thinks you're doing the square root of whatever this is first, and not just the square root of 2. So you gotta type it in as root.
She looked at us and then she shook her head and walked back in her room.
Okay.
Oh.
Type it in like this. Are we good, kids?
Yes.
Okay, and then hit enter. And then if you divide that by 4, does that match what our sine of 75 was? Okay. All right, so are we okay with the calculator, the way we want to punch that in now? Yeah? Laura, did you get it in yours?
Yeah.
Okay, I was just checking to make sure there. Anybody else have calculator issues there? All right, let's rock. Well, this next one's going to get a little bit lengthy, so my best word of advice to you on this next example, write kind of small on this one. This one's going to get kind of lengthy, okay? All right, kids, first of all, we started out with the tangent of pi over 12. You know, that could make you think of two angles in terms of radians that would either add or subtract pi over 12, but you have always told me that you work better in what type of unit?
Sine.
You work better in degrees, don't you?
Oh. Yes.
Okay. Is it okay to turn pi over 12 into degrees and then work with it?
Yeah.
Okay, let's do that first. Let's turn that pi over 12. Let's turn that pi over 12 into degrees. So I'm going to take pi over 12 radians and times it by what, kids?
180 over 5.
All right, so the pi's will do what?
Cancel.
And what are we left with degrees-wise?
15.
So 180 over 12 would be 15 degrees, right? So we're really trying to find the tangent, the exact value of the tangent of 15 degrees, okay? My friends, can you think of two angles from your unit circle chart that would either add to 15 or subtract?
45.
You want to go 45 and 30 again?
That would be so much more fun if we did like 330 and 315. Yes.
You want to know what the funny thing is?
Is
That's
it
what the
one
second
more?
hour did. They picked 330 and
Yeah.
315, and they got really lengthy.
Not like.
I say we go partway though.
Here's the deal, no matter what I pick, it's going to be lengthy.
Let's dumb it down for the dumb people.
Let's go 45 and 30. Is that the first one you see?
Yeah.
Okay, we're going to call this tangent of 45 degrees minus what, kids?
30.
Now, could I have done tangent of 60 minus 45? Because 60 is on that chart, isn't it? And 60 minus 45, would that have worked? Okay, so let's get started here. Let's go look at our rule for tangent with a difference. Is that okay, kids? I'm going to try and save you a step in writing. Is that all right? Okay, this is the rule we're using right up here, isn't it? I've got a tangent of an angle minus another angle. All agree there? Okay, so this is going to become the tangent of angle A. So this will become the tangent of what first, kids?
45.
Okay, look in your chart. What is the tangent of 45 degrees? 1. So up top you're going to have a 1 minus, and then this is where things get goofy. Tangent of 30. Square root of 3 over 3. And then this is all over 1, and then plus, okay. Kids, what was the tangent of angle A?
1.
What was the tangent of angle B here? Okay, square root of 3 over 3. So won't this be 1 times the square root of 3 over 3 right here? So 1 times the square root of 3 would just be root 3 all over what, kids?
3.
Okay. Now this is where things are going to get kind of tricky. While I agree that that's an exact answer, and I agree that if you gave that on a quiz or test, I'd probably be like, okay, they used the right rule. All right. Big idea is some of the stuff that we look at moving forward is going to want you to simplify this. Okay? Meaning this, first of all, up top here, 1 minus root 3 over 3. Do you agree that this 1 could be written as 3 over 3 so as to establish a common denominator in these top two? Okay, so I'm going to call this the following. I'm going to call this 3 over 3 minus root 3 over 3 You guys okay with that part? The 3 over 3 being my what?
1.
And then here, what could I call the 1 again to establish a common denominator here?
3 over 3.
So this will be 3 over 3 plus root 3 over 3, won't it? Okay. So from this right here, let me see if I can squeeze this in over here. This is going to equal, I want to shorten that line right there. I'm going to shorten my fraction line so I can squeeze this in here a bit. Okay. Do you guys agree that this is the same? Over here now, do you guys agree I've got a common denominator of 3 right here?
Yeah.
So can I say that this is now the 3 minus root 3 part up top, all over a common denominator of what here?
3.
With me there? How about down below here now? Don't you have a common denominator of 3 again? So this one will simply be 3 plus root 3 over what?
3.
Okay. We're getting closer. Are you following my steps so far? Okay, again, have we kind of established what the exact value would be already? The answer to that is what? Absolutely, we have. Now we're kind of in a situation where we want to simplify this. All right. You all agree I've got a fraction over a fraction there? Fractions divided by fractions are fractions multiplied by the... Okay, so I'm going to wrap all the way around down to here. Okay, so the top would stay the same, wouldn't it? 3 minus root 3 over 3. Lots of 3's. Sorry. And then this would be times the reciprocal, which is what, kids? 3 over. Okay, here's the good part. What's this 3 right here and this 3 going to do to each other? Since we're multiplying. Okay, and this is where we get really close. This is going to equal 3 minus root 3 all over what?
3 plus root 3.
Okay, we're getting close. Kids, the one thing we have always said that we never ever want in a denominator is some kind of an irrational value, and that happens when you have the square root of 3 down. Is the square root of 3 on the bottom a good thing or bad thing? That's a bad thing, okay? So here's what we're going to do. Remember this word right here? I'm going to write it over here. You remember that word? What's the conjugate of x plus 3, friends?
X minus 3.
So if I multiplied these out, what we would end up with is the inside term 3x and the outside term negative 3x would do what to each other?
Cancel.
So we basically have to do the first ones, which is x squared, and then the last ones, which would be minus what here?
9.
Okay. The way we make something like the root 3 plus 3 go away and become a whole number is to multiply what we have in a form of 1 by the conjugate of the denominator. So we're going to take the conjugate of my denominator. What's the conjugate of 3 plus root 3? Okay, so this is a part right here we're going to say, okay, I need to multiply by the conjugate of the denominator in a form of 1. So we're going to multiply both the numerator by 3 minus root 3 over 3 minus root 3. Okay. We're getting close here, and I think I can squeeze this in here. I'm going to make a little room for myself. Is that okay with you guys? Can you see that okay so far?
Yep.
Okay, give me 1 second. Oops, didn't want to do that. Oh, come on, big money, no whammies, and stop.
I wish we had that kind of thing.
I know, isn't it nice?
Yeah.
Okay, here we go with this here. We're working with this part right here now. Help me FOIL the top. What's the 3 times 3 up here going to get me? This is going to be 9. Okay. How about the 3 times negative root 3? Won't that be minus 3 root 3? Okay. How about the insides here now? This negative root 3 times 3, won't that be minus another 3 root 3? And then finally the last here, what's a negative times a negative going to get me here? Negative root 3 times negative root 3 is going to turn out to be positive 3, isn't it, friends? Okay, then in the bottom, okay, the bottom is where good things start to happen. We have conjugates of each other like this. Guys, the x plus 3 and the x minus 3 up here on my board became x squared minus 9, right? Because the inside and outside terms did what to each other? Same thing will happen over here when you multiply conjugates. So all we got to do is look at 3 squared first. What's 3 times 3 here, kids? This is going to be over 9. And then what's a negative root 3 and a positive root 3 going to multiply to be?
Positive, negative.
Minus what? Okay, well, okay, my inside would have been 3 root 3. The outside would have been negative 3 root 3. So they would have canceled. So the question becomes, what's a positive times a negative here for your last terms?
Negative.
Negative, and then this becomes root 9, which would just be what value again?
3.
Okay, so 9 minus 3. Now, guys, quick question. What's the denominator going to turn out to be here?
6.
Okay, it's just a 6 in the denominator, a good thing.
That's a great thing.
Okay, so do you understand why if I have something like 3 plus root 3, we multiply by the conjugate in the form of 1 now to make that denominator rationalize?
Yeah.
Okay, there's a lot to this. Help me combine here, guys. Up top now, talk to me. We're so close on this. What's 9 plus 3 going to get you?
9 plus or 9 minus? Oh wait, 9 plus.
Yeah, because I can combine these up here up top now, can't I?
Yeah, those can be 12 now.
Okay, and I'm subtracting 3 root 3 and another 3 root 3 is getting subtracted. So minus how many root 3's totally? All over what value? Okay, now be honest with you here, guys. Won't 6 go into 12 and 6 go into 6 now?
Yeah.
So simple form of this, how many times will 6 go into 12?
Twice.
How many times will 6 go into 6?
Once.
So we think the answer is 2 minus the square root of what? Okay, get in your calculators quickly for me, kids. So 2 minus square root of 3. See what that is? Go about 4 places on your decimal. 0.2679. Okay. Now, this was really the tangent of pi over 12 radians, which is really the tangent of how many degrees?
15.
Punch in tangent of 15.
Whoa.
Same thing.
679.
Okay. So, let me ask you a question. Was the sine one difficult? Not too bad. But was the tangent one, is there a lot of room for mistakes here?
Oh yeah.
Yeah. Okay. You'll get a chance to practice that. But again, the nice thing about these is this. Once you do get an answer in the end, can you go in and check to see if that's the right exact answer by punching that answer in and then punching in the decimal and seeing if what you have in the end is right? Okay, so let's try this next example. What time you guys go lunch? 27? Okay. I think we can get this next example done before we head to lunch. Right? Anybody need more time with that page right there?
Don't think so.
That's pretty impressive stuff right there. Just give me a show of hands. How many are on board with me? Really a matter. It's just a matter of plugging a lot of numbers in and working it, isn't it?
Yeah.
Okay. All right, let's talk on this next one. Now this next one, I did a bad job on this next one, kids. Well, I set it up in kind of a goofy way, all right? See this fine cosine of A minus B over here again? I shouldn't have typed that in there again, okay? So here's this. Get rid of that part right there, all right? Okay, now first things first here. It says find what here, kids? Cosine of A minus B, right? Okay. Given one condition, the cosine of A is equal to what, kids? But we got to make sure we're located where? Between what and what? Pi over 2 and pi. Okay. And then they only tell you what the sine of B is equal to, right? The sine of B is 3/5, but B has to be between what and what, kids? Okay. So there's two conditions that we have to satisfy. So here's what I want to do first. Okay. Over here, I'm going to call this stuff kind of like angle A stuff. All right. So I'm going to go to the top here. This has everything to do with angle A on the left, because what were you given over here, kids? Yeah, and it gave you cosine of angle A too, didn't it? And everything's relative to A, so what's everything on the right side gonna be? Angle what? Okay, let's just do this up above the problem. What are we trying to find here again, kids? Okay, you guys, let's write this down right now. Go back to your front page, somebody. Tell me what cosine of A minus B has to equal.
Cosine A, cosine B plus sine A, sine B.
So we got cosine A, cosine B
Yeah.
plus
Plus.
sine A
Sine A, sine B.
times sine B. Okay, quick question, kids. Do we know what cosine of A is already? Do we know that?
Yes.
They tell me right here, so we're good on this one. Cosine of A, I'll put a little smiley face under cosine of A. We know that already, okay? What about cosine of B? Do we know cosine of B?
No.
No, okay, so we gotta find that, right? So this one's gonna get what kind of a face? Alright, how about sine of A? Do we know sine of A already?
No.
No. Do we know sine of B? Right here it says sine of B is equal to what? 3/5. So we know sine of B, right? Guys, if there was any way to find cosine of B and sine of A, would we be able to complete the problem? Okay, so let's look at that. Let's go to that cosine of A. Let's go deal with angle A. So first of all, angle A, my friends. I'm gonna draw a coordinate plane here as best I can. Coordinate plane. Boom. Guys, it says cosine of angle A is negative 12/13, but my angle must be in which quadrant, given these, gotta be in the second quadrant. So given this range right here, I've gotta be in second quadrant. Pi over 2 to pi, that is my second quadrant. So there, oh my gosh, that's terrible, Parson. Oh my gosh, Parson, get to the board. Durka, 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 that's bad. Okay. Now kids, we've been used to putting theta at the origin lately, haven't we?
Yeah.
Be careful on this now, my friends. What angle are we talking about now? Angle A. So I'm going to put an A right down here. Is that okay with you guys? Okay, you know that the cosine of angle A is negative 12/13. So the hypotenuse must be 13. Agreed?
Agreed.
And then the adjacent leg must be what value?
Negative 12.
And it makes sense that it's negative 12 because it goes to the left of the origin. You guys remember the 12 and 13 relationship? You know the other leg? Something 12, 13? It turns out to be 5. 13 squared is 169. 12 squared is 144. That difference is 25. Root 25 is what?
5.
Should this be a positive 5 or negative 5 over here for this opposite leg then? Okay, so kids, from this triangle now, we knew the cosine of A. We were good on that. But we also needed to know what else? We need to know sine of A. Can we get the sine of A from this now, kiddos?
Yeah.
What is the sine of A from this?
5/13.
Right?
Yeah, opposite over here.
Okay. All right. Well, let's go deal with angle B. Angle B tells me that the sine of that angle is 3/5, but this one here is located in which quadrant?
The first, right?
Yep, 0 to pi over 2. That's going to be in the first quadrant. So, here comes my triangle. What angle am I going to put down here at the origin?
A.
Careful.
Oh wait, B. Yeah, B.
Yep. What's the definition of a sine again, kids?
Is it opposite over?
Opposite leg over the
Hypotenuse?
3 and 5. So what's my relationship here for this triangle? So I gotta be a 4. Positive or negative 4?
Negative. I mean positive. So it's
Gotta be
right.
positive there, yep. So guys, we know the sine of b. Can we find the cosine of b from this mess now?
Yeah.
What would the cosine of b make?
5/3.
Careful. What's the adjacent leg to b?
Oh, 4.
4 over the hypotenuse of?
5.
All right, there we go. Okay. Guys, those two things that I had frowny faces on, can we turn them into smiley faces now?
Yeah.
We figured that out. So I'm going to write this down again. So from this whole mess here, I'm just going to kind of do this. Go all the way across here now. Okay. We said the cosine of a minus b had to equal the cosine of a times the cosine of b plus sine of a times sine of b. And now I'm just going to start asking you questions. What was the cosine of a, kids?
Negative 12 over 13.
So we're going to replace cosine of a with that fraction, negative 12 over 13. Cosine of b will be, we just found it, 4 over 5. Plus, here we go. How about the sine of a? Do we know the sine of a now?
15 over 13.
5 over 13, right? Yep, be 5 over 13 times what? 3 over 5. Okay, so we've got a product of fractions here on the left, plus another product of fractions on the right. Let's see what this gets us. Guys, up top here, what's negative 12 and 4 going to get you?
56.
Ooh, be negative 40.
48.
There you go. That's all right. How about 13 and 5?
65.
Okay, and then the nice part about the second product is that when we multiply it, 5 and 3 is what value up top?
15.
Okay, so we're going to get another product of 13 and 5 on the bottom, which is
65 again.
really nice because,
Common denominator.
yes, common denominators. So in the end right here, we can simplify that. What's negative 48 and 15 going to add to? Negative 33 over what?
65.
So if those conditions were given up there, the ones that they described for angle A and angle B, and you want to know what the cosine of angle A minus the cosine of A minus B was, your answer would be negative 33 over what?
65.
65. Okay? So guys, I'm going to pause right here. When we get back from lunch, somebody remind me to pick up the recording again, okay? Guys, so I think cosine and sine are kind of doable, right? Do you understand right here that we're dealing with really how many angles now? How many angles are you really dealing with up here? 2 of them, right? An angle A and an angle B now, and then I think just follow your rules, you'll be in good shape. Okay, you'll know some of the information, some of the other stuff you're going to have to find. But okay, let's see if we can't get through example 3. Let me see what's on example 4.
Look what. Already.
Guys, I think we can get through example 3. Example 4 might be a stretch today. We'll see where we're at, okay? All right, let's talk. Guys, simplifying an expression here. So simplify the expression cosine of what, kids?
X minus 5.
Okay, first of all, is this a sum or difference?
Difference.
It's a difference. Now, guys, the things that we're going to see on this is the following, all right? We know it's a difference, so this is going to become cosine of x minus pi. Okay, it's going to equal. Okay, you guys tell me what to write, given your rules. It's a difference for cosine.
Cosine thing.
So in this case, cosine of what?
Oh, x.
Cosine of x
Cosine of pi.
times the cosine of pi. All right, I'm listening.
Plus sine of x. And then sine of pi.
Squeeze that in my box over here. Okay, you with me on that so far, kids? All right, so this is going to equal the following then. Do we know what the cosine of x is?
No.
No clue. But could you look up the cosine of pi on your chart?
Yes.
What is the cosine of pi?
-1.
So this is like -1 right here times what still?
Cosine x.
Okay, so this will be -1 times the cosine of x plus, okay, I don't know what the sine of x is, but could you find the sine of pi up there from your unit circle?
0.
Could be 0 times the sine of x. Well, that's good because 0 times the sine of x will just be what? Okay, so this part right here is going to be 0. What about this part then? What will this just become?
And negative cosine x.
So simplify or simplest form here would just be what? Okay. Good with that?
Yes.
Okay, so if I had to ask you guys to simplify the expression of, I don't know, how about we go sine of, go pi over 2, I'll have you guys try this one on your own, okay? So sine over 2, pi over 2 plus x, all right? Tell me what that equals in the end, all right? You guys try that one on your own. Anybody got an answer yet here?
Cosine x.
Cosine x. Let's check it out, guys. Do you agree that by this, first of all, be a sum rule? Would you agree with that? And it's a sum rule for sine. So tell me if I've got this right. I think it's the sine of the first, cosine of the second, and then plus cosine of the first, cosine of the second?
Yep.
Okay, so this would be sine of pi over 2 times the cosine of x, wouldn't it? Plus cosine of pi over 2 sine of x. Is that right, kids? Okay. What was the sine of pi over 2, friends?
1.
So this was 1 times the cosine of x, which would just be what here?
Cosine x.
What'd you guys find out about the cosine of pi over 2?
0.
0 times sine of x would just be 0, so what do you get in the end here?
Cosine x.
Okay, now if you remember, do you guys remember the cofunction identities that we had from the previous section? There was a section in there that said the sine. Remember what I said to look for? If you see a pi over 2, that might be an identity. Turns out sine of pi over 2 plus x on your identity chart from the last section was cosine of x. So we could have found it this way now too. Okay. You guys feel okay about these right here then, simplifying? Okay, same stuff, you just, instead of having 2 known angles, you've got one angle and a variable, and then see what you end up with in the end, okay? All right, questions so far? Let's see if we can get example 4 taken care of here, and then we'll stop there today, okay? All right, let's take a look at example 4. Example 4, I need to take a quick peek at here first. I'm not sure. Boy, oh boy, So we want the cosine of x plus pi over 4 plus the cosine of x minus pi over 4 equal to what value? 1, where x is between what and what?
0.
Okay. Why don't you guys help me with the cosine rules for those sum and differences? I'm pretty sure, double check your front page again. For this first cosine, is it going to be cosine x, cosine pi over 4, minus sine x, sine pi over 4? Okay. And then this one here will be cosine x, cosine pi over 4, plus sine x, sine pi over 4. Is that right? Okay, let's check it out. Let's write this out. Okay, so this is going to become a mess. This has got to equal what value in the end, kids? We got to find x values between what values such that this statement is equal to 1. So here we go. I'm going to call this first one cosine x, cosine pi over 4. And then it'll be minus, right? Sine x, sine pi over 4. Okay, you agree that that's for this first part right here? Okay, I'm going to put that all in parentheses for my first part like this. And then to that, we're going to add. And here we go. Second set of parentheses. This will become cosine x, cosine pi over 4, right? Let's see, what's next, kiddos? Plus sine of x. I apologize for the line in the middle, don't worry about it. Sine of x, sine. Now I can save you some time on this right now. You want me to do that? Okay, take a look at this right here. Isn't this term and this term pretty much the same thing? Where one's positive and one's negative? So what's really going to happen there?
Cancel.
They're going to go away. Okay? We want this all to equal what value, friends?
1.
Okay. The sine x, sine pi over 4, they're going to do what again?
They're going to cancel.
These are gone. Okay, now, talk to me about the terms that are left. What's true about the two terms that are left? So do you guys agree that we're now down to 2 cosine x, cosine pi over 4 equals 0? I'm sorry, that should equal what value, kids?
1.
Yeah, my mistake. You guys with me on that so far? Okay. Can I evaluate cosine of x?
No.
But can I evaluate cosine of pi over 4?
Yes.
Okay, help me out, kids. What's the cosine of pi over 4?
Square root of 2.
Wouldn't it be 2 cosine times 2 cosine pi over 4?
Not quite, because this is all one term multiplied together. It's kind of like this right here. If I take xy and add another xy like this, how many xy's do we have totally? 2 xy's added together. Does that make sense to you?
Yeah.
Okay. Yeah, that's a tricky concept right now. If there were addition signs, then yes, it would have been. If there were addition signs between these two right here, then the answer would have been yes. Okay? All right. So, what'd you say the cosine of pi over 4 was again, my friends?
Square root of 2 over 2.
Okay, so watch what I do. I'm going to call this 2 times the square root of 2 over 2. This root 2 over 2 is my cosine of pi over 4, isn't it, kids? Times what still? What expression's still up there?
Cosine.
Okay. So root 2 over 2 is the cosine of pi over 4. That 2 is still out here. That has to equal what value still?
1.
1. Okay, what are the 2's going to do right here?
Cancel.
Okay, so we have root 2 times the cosine of x is equal to what?
1.
Guys, in order for us to solve for that x, we got to get cosine of x all alone. So what are we going to have to divide both sides by? Square root of 2. Do you guys agree that from here the cosine of x would equal 1 over root 2? Is 1 over root 2 a good form or a bad form?
Bad.
Okay, so from this, let's rationalize this. This means that the cosine of x should equal, wouldn't that be root 2 over 2? Okay. Here's what I want you guys to do now. We got to find an angle such that the cosine of x is equal to root 2 over 2. In other words, the cosine of some angle is root 2 over 2, and that angle must lie between 0 and what? Pi radians. I want you to jump into your unit circle, okay? Are you all on your unit circle? Go down to the part in cosine column where root 2 over 2 happens. What's that say? 45 degrees. Now kids, the way they started that problem up there in parentheses, that pi over 4, is that a radian measure or a degree measure? So we probably better put that pi over 4 in radians measures, right? So pi over 4 being how many degrees? 45 degrees, I'm sorry, 45 degrees then would be, what do we get for that? Okay, is there any other angles that work between 0 and pi, or is that the only one? That's the only one? So what does x have to equal here, kids? X must equal. Okay, let me just show you something quickly, kids, and then we'll be done today. If I plug pi over 4 in right up here, what's pi over 4 plus pi over 4? Wouldn't that be pi over 2? Check and see what the cosine of pi over 2 is. 0. If I plug pi over 4 in here, this becomes cosine of 0, doesn't it? Check cosine of 0. This really became 0 plus 1, which is what value in the end? 1. So the x value that works there would be pi over 4. Okay. All right, kids, let me stop this here. We'll